So two types of dilations that we're going to look at is there's going to be a dilation from the x-axis and a dilation from the y-axis. So we will look at from the x-axis first of all. So when we dilate a point from the x-axis, then what changes is it's a y-ordinate that actually changes. Okay, so what we're going to do is we're going to dilate 2, 4, say by a factor of 3. Okay, so if we dilate 2, 4 by a factor of 3, and it's from the x-axis, then what you actually do is, what effect that will have, is that means that you're going to multiply y by whatever the factor is, you're going to multiply it by 3. So what happens here is this point is actually going to shoot way up here and it's going to become 2, and then 4 times 3 will be 12. Okay, so if we think about this in using mapping, then we'll think about this in general terms, that if this point was xy, then the transform point, if you do a dilation of factor 3 from the x-axis, is going to go to x 3y. Again, using mapping is a way that we can understand how we use function notation to work out the transform function. What we do is we say that here, we know that our new x value, well, it's just the same, so x dash equals x. Our new y value, y dash, is going to be 3 times that of the original y. Then what we do with mapping is we make x and y the subject. So this one here is going to be y dash over 3. So what we want to do now is think about that function. So the function that goes through that point is y equals x squared. So this is y equals x squared. And we're going to transform that function, and we're going to get the function that's going to look like this one here, which is going to be narrower. And hopefully this point 212 is going to lie on it. So what we're going to do is we're going to replace x with x dash, so that has no effect over here. But we're going to replace y with y dash over 3, which is y over 3. And you'll see when you rearrange this now, y will equal 3x squared. And that gives you it. So now we can look at this point. So when we transformed that point with the dilation of 3 from the x-axis, it became 212. So let's just ensure that 212 lies on this point. So when x equals 2, y is going to equal 3 times 2 squared, 3 times 4, which is indeed going to be 12, and you'll see that that point lies in our new function. So when you have a dilation from the x-axis of factor n, you're going to have f of x is actually going to turn into n times f of x. You're always going to times the function by whatever the factor is. So finally, we're going to look at dilations from the y-axis. So when we do a dilation from the y-axis, what is going to affect is the y-ordinate is going to change. So if we dilate by, say, a factor of, say, 2, but it's from the y-axis, and what's going to change, what we're going to do is we're going to therefore, what that does is it times is the x-ordinate by whatever the factor is, times is x by 2. So what will happen here, you see, is we times x by 2, coordinate's going to move here. And it'll go to 4, 4. So again, if we study this using a general form of it, so if we had the point xy and we did this dilation of factor 2 from the y-axis, then it would become 2xy. And if we use mapping here, that you're mapping that original point xy onto the transform, the image would be x dash y dash, what it ends up as. And this is a way of working out how we get the actual function. So here we've got x dash is equal to 2x. Y dash is equal to y because the dilation from the y-axis has no effect on the y-ordinate. Again, what we want to do here is we want to rearrange this. So divide both sides by 2. X is going to be equal to x dash over 2, and y dash, y is just going to be equal to y dash rather. So therefore, if we look at our function again, we've got y equals x squared, which that point 2, 4 lies on. So what we're going to do is we're going to do the same transformation on this function and make sure that this point lies on my transformed function. So what I'm going to do is replace y with y dash, so that just stays the same. But what happens here, you see, is you replace x with x over 2. And we will expand that, but just to see if this works, we're going to sub in the point at x equals 4. So x equals 4, that's going to go 4 divided by 2 is 2. 2 squared is going to be 4. You will see that that transformed point will lie in my transform function, which I can obviously tidy up a little bit and write it as 1/4 x squared, or whatever form you want it in. Again, subbing in 2 here, that'll be a quarter times, so it'll work. 2 squared is 4. Okay, so that will all work. So basically, when you're doing a dilation of factor n from the y-axis, then it is always dividing by the factor.